Welcome to solverfy.
Hello, my name is Margaret, and today I'm going to be helping you with a problem from Chapter 8 of Chemistry, the Molecular Nature of Matter and Change, the 7th edition. And this is problem 23. And the question states, it's just asking to write out the full ground state electron configuration for 3 different elements. Now, before we get started, just a quick note about the easiest way to remember the exact order of all the orbitals is the best thing you can do is you don't have to remember the whole diagonal thing, but if you want to memorize that, that's perfectly fine. But all you really have to do is just remember exactly where each of the element blocks is. And from there, just know that it's exactly all in order. So, here we have, 1s, and then here, and that's for this. And then we have 2s and 2p. And then we have 3s and 3p. Then we come down and we have 4s. And then we have 3d. And the electron configuration goes in that order. It goes 3s, 3p, and it loops back around. It goes 4s, 3d, and then comes back to 4p. And then goes 5s right here, and keeps going to 4d for this next section. And the same happens for the F block elements all the way down here. They fit in right here in the electron configuration. So if we get down here to 6s, the next thing will happen will be this row of F block elements. It's just that the level, the number in front of it, as opposed to being 1 less like the D elements, it will be 2 less. So this is 4F, and this is 5F. Okay, so you just have to, if you can keep these sections straight in your head, then it goes in the exact order line by line, which I've always found to be much easier than trying to remember the diagonal thing, because that's where I typically get confused, and that's where I will get them out of order, whereas I have to know already where each of the element blocks are. So with that being said, let's go ahead and get started on our homework problems. So the 3 elements we have are rubidium, germanium, and argon. And we'll go through them pretty quickly because these problems are typically a matter of memorization once you understand these patterns. So our s orbitals hold 2, our p orbitals hold 6, and then our d orbitals hold 10, and then our f orbitals hold 18, if I'm remembering correctly, but we won't need to use those right now. So starting off with rubidium, okay, we can locate that. That is right here, okay? And in that position, it ends on 5s1, okay? And this is how I typically solve these problems. I figure out where the element is, what will its last orbital position be, and then just, going row by row as I look at the periodic table, start filling them in. All right, so we start off with 1s1, or 1s2, 2s2, 2p6, right? Because we have the first row and the second row, and then 3s2, 3p6. Then here's where things start to get a little trickier. We have 4s2, and then 3d10, 4p6, and finally 5s1. Moving on, we have germanium. And that element is over here. Okay, that's in the fourth row over here in the P block. So it's going to be 4p2 is its final place. So from there again, 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10, and then 4p2. And then finally we have argon, which is right over here. And it's here in the third row in the P block again. And its final place is going to be 3p6. 1s2, 2s2, 2p6, 3s2, 3p6, and that's the end of that one. All right, so